Rod, you're giving me a big head back there. It's going to be hard to get out the door when this is over today. Ladies and gentlemen, this next session is going to be very interesting. It's called Building on BricsCAD BIM. And we have four separate segments in this next hour. The idea is to talk to you about developers who are building on BIM, but also we want to start with a customer success with BricsCAD BIM. McConell Dowell is a customer of ours in New Zealand. They are a construction firm, they employ about 5,500 people. They've been doing a lot of work in Singapore, and they're doing some very unique work demolishing an existing building and building a new building. But I think you'll find this is a pretty interesting development. And with that, I'd like to invite Shivdeep Garad to the stage. He is our software development lead in our Singapore office, and he's focused on customer success. Shivdeep, thank you.
Thanks. Hello? Okay, it's fine. So thanks, Don, for that introduction. I lead the Singapore development team, and I also am driving adoption and usage of BricsCAD BIM in Singapore. So this is a case study about McConell Dowell, and so let's begin first. They're our customer of BricsCAD BIM. They're using it now. Where is Singapore? So it's supposed to be a tiny red dot somewhere here. So we have to zoom a bit, and then we zoom, and it's still a tiny red dot. Okay, so it's small. It's about 40 by 30 kilometers, and it's a population of 5.6 million. Kind of corresponds with some of the cities. What's interesting is that the GDP per capita is about 57 or 58,000 US dollars, which is kind of matches with, or matches with the some of the developed countries like the US or countries in Europe. The other important thing is there's a lot of, okay, now, despite the training, I managed to do this, yes. Okay. The other thing is that the construction spend, the public sector construction spend in Singapore is going to be 24 to 27 billion US dollars per year. That's not spread over 4 years, but per year for about, the forecast is for 4 years. That pretty much means there's a big opportunity there. There's a lot of money to be made, and BricsCAD BIM should be getting a slice of that pie there. Another interesting thing about Singapore is that the government drives a lot of initiatives. So the government is driving BIM. I also want to, they're quite interested, and they want the entire submissions and everything to be on BIM. And I'm glad to also mention that after 1 year of trying, we've made inroads into BCA, which is the Building and Construction Authority. So now Bricsys is part of the industry partners with whom BCA is talking to make sure that BricsCAD BIM, to make sure that BIM is implemented in Singapore. So it's kind of happy to hear the officer from BCA saying, oh, the customers can use Revit, they can use ArchiCAD, they can use BricsCAD BIM. I say, wow, that's brand recall, right there. So those are the good, interesting things about Singapore. Now, BIM, traditionally you thought that it was for architects designing fancy buildings like the Twisted Tower, yes? But, well, it's not necessarily like that, because there's a much larger segment out there, which is contractors, not so glamorous, but they are huge. And as you can see from this slide, that when you see the division between the hard and soft costs, and the architectural fees are about half of, well, 15%, so that's about 7% of the total project cost, but a bulk of that, it's a 64. So about 65 or 70% of that is on main cons. So if you see the contractors, they have a lot of money to play with, and for them, buying a few BIM licenses is not a problem as much as for architects. So that's a segment that is interesting. And why is it relevant for our presentation? And these guys are more interested in construction and execution and not design of the buildings. So why is that interesting? Because McConell Dowell, it's based out of New Zealand, and they are an infrastructure construction company. They're big, 5,600 plus employees, mostly in the Southeast Asia, New Zealand. But the large-scale projects are in Singapore. They've done quite a few large projects in Singapore. So when we talked with them, what is it that their objectives are for BricsCAD BIM? They said that they want to make BricsCAD BIM their main software. So that's going to be the main workhorse. And we often hear when we go to customers like these guys, they say, oh, we don't get to choose the BIM software we use. It's usually dictated by our clients. But here, even though the clients would use the other software, they say that they want to have a bare minimum, like a communication layer and they're going to maintain the bare minimum licenses of the other softwares, but they're going to get it inside and they're going to do the major work in BricsCAD BIM. And how they are able to do that, we can see, but their objective was to do temporary works, which facilitate the construction of the main design. So they want to design the temporary works. They also are looking at tendering, so they want a rapid turnaround. You know how it's just madness tendering, right? It's so many tenders, there's never enough time to do all of them. So they have to be fast, and for that they need to give cost estimates, they need to give a confidence to the clients that they can do it. So I was having lunch at the Stamford Hotel, which is at the 70th floor. And I was just looking around and I saw this and I said, hey, wait a minute, that looks like the one that BricsCAD BIM is at work. So I took a picture of it and put it in my presentation. It's fun to see the stuff that you're doing, developing is being used here. So what did they want to do? Since I said, well, this particular project is to demolish. This is the Marina Bay Sands, and there's as you can see, the site is out there in the middle of the water. So they want to demolish the existing construction. They want to do a new construction. And for doing that, what they're going to do is import the existing structure, the IFC model, in BricsCAD BIM. Then they import and overlay the new structure again in BricsCAD BIM. And they model the temporary works around it. This is how it looks, huh? Not very fancy. But as you can see, there's two interesting things about it. And one is that it's not the usual doors, windows, rooms, columns, beams. It's not the usual stuff. So that's also interesting because BricsCAD BIM is flexible enough where you can pretty much, I'm getting ahead of myself, but that's what they did. And the structure to be demolished and constructed is in the middle of that. So let's go to the first thing. How did they do quantity takeoffs? So what I was saying is, they were able to model the whole thing in 3D. They don't need to bother whether they're modeling walls or rooms or columns or whatever, but they just do 3D models, basic 3D models. And now they can go and attach the BIM information to it the way they want. So they want to do quantity takeoffs. So what they do is they add BIM information, which is timeline information like maybe phase, the phase or the time or the month or the week, whatever, to that particular element. They can also add location information, they add material information. The final objective is to get a question answered, such as, how much concrete do I need in phase 2 of this area, which has a compressive stress of 40 megapascals? This kind of stuff can be done by, I think yesterday in the BIM demo, there was some mention of the project browser. This is the structure browser. I think I saw this as well. They had typed a query up there, and it's incredibly powerful. I mean, it's gotten more powerful than what I knew it was. But you can actually perform such queries, and then you can get the information that you want. And you can plan out your, you know, how your construction, what materials you need to order, at what point of time, how much you want to invoice your client, because you need to manage your cash flows as well. The other thing they wanted to do is a timeline. So why is this important? According to them, this is part of the tendering process where you go and present, and it makes a good impact to the customer. The customer sort of knows that you know what the problem, what the thing is, how to do it. So here as well, the structure browser is very helpful. You can sort the various items by a certain, let's say, week 1, week 2, week 3, week 4, and then you can hide and show various stages of the project, so you can actually show the thing getting constructed phase by phase. We hope that in the future, you saw some nice animation of the excavator. We hope that in the future this is what they want to do, because they actually at the moment they usually try to present an animation as well of the thing getting built, you know, the cranes moving around and all that stuff, just to give the user an idea. And the cranes are just there swinging around doing nothing, but it shows that they know that you need 4 cranes. You need, you know, you need some other equipment. They're going to animate that, so that's the next step, but that's not done as of now. But again, BricsCAD BIM, we can do that. So here is how they presented the timeline to their customers. There's site preparation, they demolished the promenade. This they were able to do through BricsCAD BIM by hiding and showing certain elements. They demolished the bridge, do the piling, create the deck, the metro deck, and now they can actually drain out the water and start demolishing. They have the new bridge construction, the new structure construction, and the decking removal, and finally the steel framing removal, and the final thing. So this is the timeline that they showed to their customers. This, of course, earlier they were using SketchUp to model the thing so that they can export it to an animation software. In the animation software, since SketchUp is surfaces, they have to again collate a bunch of guys and assign them materials and whatnot. But BricsCAD BIM, once you assign materials, you do a collada out, it comes into the animation software right away. So, and then you can further go to IFC out and do whatever you want to. So you can see that in the future, what kind of promise this offers to them. And so in conclusion, what I want to say is that the takeaway here is that for resellers as well, is that don't just focus on architects. There's a big segment out there which you can go to, and you can actually have these kind of value propositions. Don't worry if they say that we are dictated by our clients, because there is a way around. We've shown that, and we certainly hope to replicate this success in other construction companies as well. Thank you.
Wow. So, kind of an unorthodox use potentially for the BIM product. We model buildings, they model the foundation for buildings, but more importantly, this is approximating some 4D work, right? We're starting to talk about the timeline and things changing over time. That's pretty amazing. Next, I'd like to invite the team from AX3000 up onto the stage. These guys are application developers that build on the BricsCAD BIM API. So the whole idea is here they do heating, ventilating, air conditioning, and sanitary systems. And their work is based on actually analyzing and building these systems out in BricsCAD BIM using the API and our systems.
So, wow, this is the audience. I want to start my demonstration today first with a video. Why I want to start this with this video? We have started to develop HVAC system or CAD systems 40 years ago. We have started to develop our own CAD kernels, and in the year 2000 we have switched to the A company. Then we also used the LD version at that time, and the problem was that when it was closed we were searched to another CAD kernel we can use. So we found BricsCAD with the version V9 at that time as a cost-effective software on the market, also with the availability to, yeah, sometimes I'm not an English native speaker, so I'm an Austrian, I have to try. With good performance, with the possibility to use an AIX or a BricsCAD file or to convert our old software in a very fast way. What you see now is the logic we use starting from the beginning. So the logic in our system is always a line, because nothing is easier to draw than a line. To generate a system for MEP or for heating, ventilation, air conditioning, you have a line as a placeholder for the pipe or for the duct. You have a load at the end. It could be a radiator, ventilation outlet, a sanitary object. And you have a starting point defining the system, the medium, the material parameters. So this is the logic, the idea behind our software. After the movie, I want to use two models you have seen already in BricsCAD BIM demonstration yesterday. One is the twisted tower. The person from Singapore before said the crazy one. And I want to use the smaller single-family house or the villa to show the proposal or the functionality of the BIM combination with all the calculations. So let's start and finish it. So in this case, you can see the spiral tower designed by during the BIM presentation. If you have a system like this, it's sometimes a little bit, it needs a little bit time to organize it. And if you have large buildings, it's also necessary that many people can work at the same time. So with BricsCAD BIM, and also with the possibilities of BricsCAD with external references and so on, it's quite easy to find a solution. So as an example, I will catch now one floor. So we always try, as a side explanation, we always try to use the latest functions available and also the latest APIs available in BricsCAD BIM. So we also use, for example, the floors and so on. So it's quite easy, for example, to switch. I don't know, I want to work in the 25th floor. So 25th floor, yes. The point is why I use in this floor. Yesterday we also heard, I think Mr. Kaiser was it, we need 3D models. Everybody is talking from 3D, but at the end I need a 2D plan view. So if you model a system like this, there is only the way to say, make everything in 3D. We see it also here for the timeline and so on, for the mass list, for the calculations. But at the end, I need a 2D plan view. So I've switched to the plan view, and I use my BricsCAD standard interface, for example, to use a wireframe mode, to go to the top view and see the problematic of this building. At the outside area, you have always the same. You call it Blockify, for example. So if I switch maybe to the next floor and to the next floor, and I go on to the next floor, I can see the problems of the building. Outside I have the same. I can use external references, internal not. So I have to do it in the composition of the building. Why BricsCAD can help me? So now I can see there's an unfinished element. I use the quad, for example, to modify, to open this external reference. You can see the same as we had before in the movie, in the video. I use standard lines as an element. I have load points at the end. I have a starting point at the beginning. And also here I use the possibility or the functions of external references to switch the plan view on and off. How to design a system. So if I have an existing element like a block, I can use the block. I use standard CAD functions like copy, for example, CO. Normally I have a German one, so I have to think in English. I can place the element. I need a connection. So I switch in the user interface, I activate the connection function, I select the line. But at the end, if I select the element, you can see it's only a line. Also, the structure browser is quite interesting because we are using also this API at the moment. So all the elements are defined automatically as the correct, correct ventilation element to the correct floor, to the correct building, that at the end also the IFC interface can be used to export and correct and real ventilation duct into the IFC interface. But now, let's try to get a ventilation duct, and this is the easiest. At the point I select only the system, I wait a second, and depending on the lines, the load point at the end and the starting point, the software is calculating a duct. It's not only a drawing, it's a calculated duct. That means that the dimension of the duct depends on the flow rate, because the load point at the end, the ventilation outlet, knows 200 cubic meter, 300 cubic meter, and you can see an Excel logo opened, because also the calculations are done in the same step. So now, instead of the line, I have a ventilation duct. I know all the values, and the elements are also implemented into the building as a flow fitting, flow setting, and so on. If I close it, now the system continues, so I have to reload the, you've seen the functionality yesterday too, to reload the system, to get it connected into the plan view, and now we have to connect the floor to the core, and there's the same logic than before. I have a load point, but this load point is connected to the other drawing. So the load point knows automatically the flow, and I do the same step than before, but maybe without an Excel list. So this was the first step I want to show you, how is our software implemented in Bricsys, and what is the way of working. So now the connection to the core is done, and I can go forward in the next step. So this was the first part of my presentation. The maybe more important part, so I go to recent files and open the villa, is how to use the BIM model for walls, for windows, for doors, and also what is the result at the end. So if I use this example, it was done maybe yesterday from the colleagues, but it's the same building. I use a functionality, it's called define or acquire room. Normally, if I have no BIM model, a few weeks, a month ago, I have to use polygons to do this. Now, I only press one button to say, please, I want to use BIM rooms. I press OK. At this point, the entire model is readed. I can see all the rooms of my model, which rooms I want to use. I can activate. If I say OK, everything is done. So to make a load calculation, to generate, we call it room book, because the room book is the basic of all our calculations, will be generated automatically from the BIM model without doing anything. To check this a little bit, maybe I switch the shading mode and I switch off the walls to have a little bit better view. We use our room manager, we call it room manager. Takes a few seconds. The room manager is used to do visualizations. So I can visualize one room, another room, a second room, or maybe all rooms of a floor. And now the important thing is the color should help the user. We are visible people. If you have different colors, you can analyze it graphically. You can find out mistakes. So if I have different wall types or identical wall types, I can see it in the same color. But the same can be done. So if I use, for example, to the office room, look down at the bottom. I move it up first. There I can see a transmission load, a ventilation load, a norm heat load. The calculation is done automatically because the BricsCAD BIM room knows the connected wall and surface. The wall knows the connected composition. Depending on this, I have a transmission load through the wall, also the window, according to in order of the glassing type and so on. And depending on this, now I also want to check if there is something maybe problematic. So we only switch in another view, and I can say, please show me the transmission loads of the building. So I can see everything is green. One area is a little bit yellow, so there's a huge glassing facade, more transmission load. Show me the U values, show me maybe what is the internal wall, what is the external wall, what are the room temperature I was using, and what is the watt per square meter value I have to cover by the heating system. So this is automatically found from the BricsCAD BIM model into the calculation. Okay, this was static calculation. I've used the coldest temperature outside, the hottest maybe inside. To go one step above, it's also possible to make building simulations. So what is the difference? For a standard load calculation, you take one temperature, maybe the coldest of the day, and you calculate this value. For a building simulation, you use an entire year, and you need the temperatures hourly. This you can get from some meteorologic stations, from software called maybe Meteonorm or something else, and you need a simulation kernel. To develop this, it's the work for a life. So the simulation kernel was not developed by our company itself. It's one of or you can nearly say only one interface we have, and this is the interface to a simulation kernel called Energy Plus, developed by University of Berkeley. So to do the simulation, we have another type of room manager. So you can see I have 4 different areas. I have zones, I have rooms, I have schedules. So if I take a room, I move it to a zone. That means the zone is for me the main thing. If I have many office rooms, I don't want to define all the internal loads, all the schedules when it's heated and not in one step. At the other side, at the project, I can select my weather information. So for example, London Gatwick or America, whatever. Maybe New York or something else. And the zone needs a profile. So according to, at the profile, is defined when the room is heated, when the heating is switched off, what is the temperature, at what time, what day is switched on, what day is switched off. And now automatically in the background the simulation is done, and I can go to the results. So for this kitchen room, the calculation was done, and I can see the maximum load is 6,500 watt on somewhere in June, 30 of June in summer. Why? It was a very large room, and I have a glassing facade direction to the south. So I can go forward to say, okay, what happens if I plant a tree, some shading areas, change the windows and so on. Or what is on the coldest day, what is on the hottest day maybe, the period for the day, what is the day curve of the room temperature. So also these calculations can be done automatically. At the end, in order to the calculation, you get radiators. You can see here. And now we're at the same position that we started the ventilation module. They are placed by the software under the window. You can do it, you can manage, you can manipulate. You connect the radiators to the line. So I select my 2 radiators. I say this is the flow, this is the return. So I was a little bit too fast. Confirm, flow and return. No. Let's do it in a plan view. You can see everybody wants to try to model in 3D, but sometimes it's easier to do it in 2 dimensions. Connect. Flow and no. Let's try it with the difference so it's easier. I try to hurry up. I have exactly 40 seconds. So. Return. Oh, we have only connected 1. And so at the end, I start the calculation process. I select my windows, or with the window, my system. The calculation is started. The load at every position is calculated. Because of the starting point, the software knows that the medium is at the moment water. I have a density, a velocity, a heat capacity, so I get a pipe dimension, and at the end, I get a mass list and a physically correct calculation. And last but not least, we have only one module, but this I only say in a very short step. This is we use for virtual reality, but not in case of doing some interior or exterior designs. We use it mainly for maintenance or to check the ability to mount the ducts. It's also implemented directly in BricsCAD. You have one button you have to press, and the entire BIM model of BricsCAD, or also a solid model, is sent directly to the VR kernel. So I open it only one time. takes less than 20 seconds. You can see as an example, it's only a ventilation kernel. I went to the module, I press one button. It takes a few seconds, you can see the green button. An Unreal Engine opens, and I get the model directly in the kernel and can go fly or go through my building to look if I have some collisions or problems where I can check something. Flight mode, Shift W. So, that's all.
He said, "That's all." Like, that's all. Pretty amazing. Pretty amazing.
I have only 15 minutes, so.
Wow. So I think that you could see that because of the decisions that we made early on in the design of BricsCAD BIM, the use of solids. People keep asking, why do you use solids for BIM? I think we've proven multiple times in these last few days why we use solids for BIM. One of the things Eric talked about the other day was simplicity and also leveraging and raising the level of complexity across the entire model and doing that in an intelligent way. The folks from Parabuild have a structural steel detailing system that allows us to generate high LOD fabrication drawings directly from a model in BricsCAD BIM. Thank you. Welcome.
So like Don says, what we do is we model a fully detailed steel structure in order to generate from that shop drawings and GA drawings, CNC files, bill of material, etc. So we'll show a live demo based on the Bricsys Gemini project. And you see on the outside here the steel structure. That's what we'll be working on, and we'll open that in a separate drawing. And these are LOD 200 objects. So LOD is level of development, we call it, because it's design stage. And Parabuild elements we call LOD 400 because it's fabrication stage and fully detailed. So first, well, you can just start drawing in Parabuild. You don't need to do a conversion. This happens in the background using the BIM API. And so we'll first look at a special case here. So these 50-meter long columns, you can't actually purchase these long columns, so we'll split them up into multiple columns. And when we do that with the break command, they actually stay linked to the original column. So when the original column changes, moves or changes size, the individual ones all stay linked. All right, so we'll start adding connections, like this splice connection at the break here. And then we'll use propagate to copy it to the rest of the model. And in this case, the model's all the same section sizes and 90 degrees, but propagate can go to different, copy to different sizes as well, or different angles, etc. And Jeff will add more connections, and I'll just explain a little about what connections, how connections are made in Parabuild. So what you do is you take a template drawing and you just add geometry and constrain it in the template drawing, and you can use simple equations as well. And then you put it in the library, and then it can just be used like any other connections. So this means users can expand Parabuild by making their own connections or changing existing connections. And what Jeff is doing here, well, in this case, the connection doesn't actually exist yet. So what Jeff is doing, he's taking smaller connections and combining them into one. So he's taking a few cleats for the beams against each other, and then on top he's adding a cap plate. Then he merges them into one, and then he propagates the whole. At this point, you could also put this connection in the library, but right now we just use it to propagate. And if you have a connection in the library, all you have to do to insert it in the drawing is select a general connection type, and then select the members you want to connect, and the library is scanned for all the valid connections for that particular situation, and then you get these choices, you pick one, and it's applied. So Jeff is constraining all the separate situations and then propagating. And the corner here also needs a different cap plate. And a few cleats. These cleats are important because afterwards we will connect the bracing to it, of course, and for the strength of the connection. Add a cap plate and propagate. And that goes to 7 other locations in the model. And then this is a similar situation, but the beams are collinear, so we need to treat that as well. And I think that will propagate to about 30 or 50 locations in the model. And then in this case, we'll just do part of the connection because there's actually no connecting element between the two beams. We can just do one side and propagate it to the other side and also to 300 other locations in the model, creating over 700 cleats and more than 2,000 bolts. And now they are all connected. And I think we need to do a few more connections. Also the horizontal, yeah. This is the same as before, except horizontally. It propagates to about 50 locations. And then we'll do a simple connection for this rod bracing to the cleat. So usually in LOD 200, rod bracings aren't reliable about where they're placed, so you might have to change them, but that's easily done. You can break the link between the LOD 200 and 400 so that you move these bracings and they don't update with the rod in LOD 200, but here we just use them as is. So now these bracings were propagated and everything. I think we're about done with connecting this model. So now we'll look at, we'll go back, the LOD 200 model is still there. We can just change visibility, and now you see this is the LOD 200 model. And just to show you what happens when we change this model, we'll move part of the building left and then show you the LOD 400 model. So this is quick and dirty. You'll see a gap. I don't think the move is working. Okay. You see a gap, but doesn't matter. Just showing a point. If we then go back to the LOD 400, you can see that the connections all fixed, the beams and the columns were moved, whose LOD 200 columns were moved. So we're also going to add a staircase to the outside of this building, and to start, we'll insert a staircase template we made in advance. So just like connections, these templates can contain anything, a full staircase or trusses, bracings, a full building, etc. And we can change the size because it's fully parametric, fully constrained, so we can change the size by changing some of the base planes, and you see everything adapting. Now, let's look a little at these gratings. They're actually constrained as one element, so it's just all these crossbars and load bars. They're just one element. You just have to constrain the sides. You can just select a different grating from the library, and these steps as well. They are from a parametric template drawing, so you don't have to have 100 steps threads for all these. You just have to constrain one thread in a drawing, and a different size is just a matter of different parameters. So let's first look at how we create such a template. So this is basically the base for all that staircase. It's just two beams constrained between some bases. And if you change the number of floors, because each floor has two beams, two platforms, and you get what you expected. We call it a smart array. This doesn't seem so smart, but the smart comes in when you add more geometry to it. So we'll use several other templates we made before. So this is a flight of stairs, and we'll put it on the first floor. And when we then change the number of floors to 2, this is automatically copied. And when we now, between the two floors, put another flight of stairs, then the smart array will also check these dependencies and put between all the subsequent floors, put these stairs as well. So all of these stairs are fully constrained and will adapt to changes of the floors. So let's look at the completed model, and we'll make one more change here at this platform. So we'll make a gap so you can actually get in on the staircase and just apply a returning rail connection here instead. So this completed staircase, it has the flights of stairs between the beams, and then on top of that has railings on the stringers and on the beams. And then there's another smart array of posts and between the railings and the stringers. And between those posts are near rails between each post. So when you change then the number of entries to 8, because there are 8 floors, all of these dependencies are checked and copied, and the constraints are copied with it, and then you have a fully constrained completed floor. But in this case, our floors don't line up, so we need to change the floor size to 4,200, and except for the first 2 floors, they are 4.2 meters, 4.5 meters. So every floor can be a different size, and the number of threads will be adjusted, because that's also done with a smart array that will adapt, and the number of posts will adapt if needed, etc. So now you can see that everything lines up. And just to show that each staircase is its own thing and not just a copy, we'll change the thread size here. Just choosing a different one from the library, and you can see that all the connections adapt, the railing adapts, and the connection to the platform adapts, etc. You can change the number of posts, and when you do that, there are more near rails created, and you can see that we just did it with one of the stairs, and the other ones stay the same. You can make each one unique. All right. I think we're done with modeling, so we'll quickly show some of the output. So in this model, we just created 7,000 bolts and almost 4,000 parts, like these threads, plates, cleats, members. So to compensate for that, we have a numbering system, and that will detect equal parts. And so this way, equal parts and equal assemblies as well. This way you can get only one drawing for each assembly, and you get a count of 300 of these. And we generate a bill of materials of various types. This one is an assembly list. It just tells you which plates are welded to which members. And then we can generate automatic position drawings and assembly drawings. We don't have time for a lot, so we'll just show one assembly drawing. It has automatic dimensioning, and the dimensions are optimized so they don't collide with each other or with any of the geometry. So here you see one of these assembly drawings of a column, the corner column, and then you see an extra view added for the base plate and for the cap plate at the end, and they also get dimensions. And you see that the corner columns have 4 occurrences in the model. All right, so we also generate CNC output like DSTV and DXF. Now DSTV is just a number, it's just machine language, just a number of, it's just numbers in a file, so we'll just show a DXF file of this cap plate. And the DXF file is used for the machine to know what size to cut, where to cut it, and where to drill. We'll open that. And you also see that there are contour lines added optionally. These contour lines are scribed by the machine, and this way the welder knows where to weld these parts together. And you see the labels you see are also scribed, and they tell the welder which parts to weld together. All right, so one final thing to show. We also export and import CIS2 and IFC files, and then there's a special case with Bricsys. They made an export reactor, so when Bricsys exports, when BricsCAD exports IFC, they call upon our elements to attach our elements to this IFC export, and you get a combined IFC file. And this is the Gemini building. Instead of the LOD 200 elements, we replace them in the combined file with our LOD 400 elements. All right, so that was our demonstration. Thank you to Bricsys for making all these APIs, and thank you all for listening.
Wow, thank you, Rudy. Thank you, Jeff. That was pretty amazing. I again, reinforcing this 2 ideas, working in solids, which people said, why? But more importantly, the BIM API. And as Luke has told many of you, it's about 2 or 3% on top of the existing API for BricsCAD. But it gives us the power to allow applications like Parabuild, like AX3000 to link directly into BricsCAD BIM. Another thing Eric has stated multiple times, we don't want to be experts in all of these disciplines. We want to enable and allow the best developers to build the best applications that work with BricsCAD BIM. And I think you've just seen 2 really shining examples of that and what people can do when they have access to the right tools and the right system. Now, it's one thing to show construction documentation at LOD 450, but in order to get to that point, first you have to sell the concept. So the next session we're going to do, Alan Brito is here. He is an expert in Blender, which is the open source software that does some incredibly beautiful renderings. And the one link that we needed to be able to send BricsCAD BIM models to Blender was FBX output, and that is now in its first release in, or will be very soon, in BricsCAD V19. So Alan is going to show us a little bit more about the visualizations that he was able to create from the models in BricsCAD BIM. Alan. Thank you. Welcome.
A short time, and my computer just froze. As an architect, visualization is an extremely important part of the workflow, because before I get to the point where I will create or work on BIM or do technical documentation, I have to sell my idea. I have to approach the client and convince him that my idea is the best solution for his problem. And I won't be able to do that using technical documentation. I have to create something more compelling, like showing him how his project, how his future living room, office, his building will look like. And you can use a software like Blender. Blender has a killer feature that's really hard to beat. It's free. And it has a really powerful render engine called Blender Cycles. On top of that, you can use other softwares, other render engines like V-Ray, Corona Render, to also create visualization. And Brics will soon have a feature that will allow you to export a project as an FBX file. Can I say that? Sure. And you will be able to get any project from Brics and use that in Blender or any other software that does support FBX files. Let me show you here. Let's get the FBX. Here it is. You may find this project familiar. Let's say you are trying to sell this idea, and you want to get your client or anyone else to buy this idea or as the best solution for their future house. If you start to show the project, let me try to go inside here. Here it is, a view of the living room. Not really compelling to show someone, here's your future living room. Since we don't have much time, let me just jump to using a software like Blender. You can import high density meshes to add furniture models, to add textures, materials, and realistic lights. Here is a view of that same living room, now with some high density meshes. It looks a lot better, at least with some furniture models. And you can, let me just show here the kitchen. It still doesn't look that good to show to a client, hey, here's your future kitchen. If you get, let me see here. can get a camera and start to render this project. Let me just reduce. It will take about 5 to 6 minutes to render an image here. Since we don't have that time, let me just start to show how the process works. Since we don't have that time, let me just show the finished models. For instance, that camera from the kitchen, after a few minutes, it will look like this. The living room. Another view from the living room. Here's a view from the space. This one will probably sell the project. Will convince the client that my idea will be the best solution for their needs. And Blender has a renderer, like I was saying, Blender Cycles. That's really easy to use because it's based on real physics. You just have to create here to get that same lightning effects. You just have to create a white background, add a sunlight, and that's it. You just have to start rendering and you get that same image that you saw here. Blender is a great solution for someone, for instance, that's trying to switch from an Autodesk solution, if they are trying to move away from like 3ds Max. A lot of people, they are trying to use AutoCAD with Revit and rendering their projects with 3ds Max. If they switch to BricsCAD, they can use Blender as a companion software to render their projects. And that's it. Thank you.
Thank you, Ellen. So I think, again, you can see that when our customers ask for something, we can generally respond in a fairly quick manner. Eric, I know this was a project that the FBX output was not, well, it's not in its last phase at this point. It will be totally usable in V19 to do the types of renderings that Alan's created. And this was something that was a fairly quick request.